The intuitive trap. Imagine you are standing at the edge of a cliff. You look out and you see the horizon. You know that if you travel to that horizon, you will see a new landscape. And if you travel to the edge of that landscape, there will be another. We are creatures of boundaries. Our brains evolved on the African savanna, designed to understand concepts like inside and outside. A cave has an inside, the forest is outside. A cup has volume, the air surrounds it. Every object we have ever touched, every space we have ever navigated, exists within something larger. So, when astronomers tell us that the universe is expanding, our primate brains immediately ask the question, the obvious question, the child's question. If it is getting bigger, what is it getting bigger into? If the universe is a balloon being inflated, there must be a room containing the balloon. There must be air outside the rubber skin. There must be a void. And if we could fly a spaceship to the very edge of the universe, to the skin of the balloon, and we punched a hole in it, what would we see? Would we see an infinite white nothingness? Would we see other universes? Would we see the face of God? This question keeps us awake at night. It feels logical, it feels necessary. But modern astrophysics has a disturbing answer for us, an answer that violates every instinct you possess. The answer is that the question itself is wrong. There is no outside, there is no room, there is no void waiting to be filled. The universe is not expanding into anything, because the universe is all there is, the expansion of here. To understand this, we must break our understanding of the word move. In 1929, Edwin Hubble looked through the telescope at Mount Wilson and realized that the galaxies were rushing away from us. The further away they were, the faster they were fleeing. At first, we thought this was an explosion. We imagined the Big Bang like a grenade going off in an empty room, shrapnel, the galaxies flying out into pre-existing space. If that were true, then yes, there would be an outside. There would be an empty void that the shrapnel hadn't reached yet. But that is not what is happening. The galaxies are not moving through space. They are sitting still. It is the space between them that is stretching. Imagine you are an ant standing on a rubber sheet. You are standing next to a crumb. Suddenly, someone stretches the sheet. The crumb moves away from you. But the crumb didn't walk. You didn't walk. The floor itself created more distance. Now, imagine that rubber sheet is infinite. It goes on forever in all directions, and someone starts stretching it. Everything moves away from everything else, but there is no edge, there is no end to the sheet, it just gets less dense. This is the reality of our cosmos. The Big Bang did not happen at a point in space. The Big Bang happened everywhere at once, because everywhere was infinitely small. Space itself is being created. Right now, in the room you are sitting in, the distance between your eyes and the screen is expanding infinitesimally. The distance between Earth and the Moon is expanding. We don't notice it because gravity and atomic forces hold us together. We are bound tight, but out in the great voids, between the galaxy clusters, where gravity is weak, new space is bubbling into existence from nothing. So, the universe isn't expanding into empty space. The universe is manufacturing space. The definition of nothing. This brings us to the linguistic prison we are trapped in. When we say nothing, we usually visualize empty space, a black box with no atoms in it. But in physics, empty space is not nothing. Empty space has dimensions. It has height, width, and depth. It has time. It has quantum fields rippling through it. It has metric. It is a thing. It is a fabric. When we ask what is outside the universe, we are asking what space exists where space does not exist. It is like asking, what is north of the North Pole? If you stand at the North Pole and take a step, you go south. There is no North Earth. The concept of north simply ends. The geometry of the Earth defines it. Similarly, the geometry of the universe defines space. If you travel to the edge of the universe, if such a thing exists, you cannot step out, because there is no out to step into. There is no where, there is no when, there is absolute null. Not darkness. Darkness is something, not silence. Silence is something, just the end of the concept of location. But human intuition is stubborn. We scream, but there has to be something. And perhaps there is. Just because our mathematics stops at the edge doesn't mean reality stops. What if the rubber sheet of our universe is floating in a higher dimensional ocean? What if the outside exists, but it is composed of dimensions we cannot see, cannot touch, and cannot comprehend? To understand this, we need to flatten ourselves. We need to become 2D creatures living on a sheet of paper. Flatland. Imagine a race of beings that are perfectly flat. They live on a giant, infinite sheet of paper. They have length and width, but no height. They can move forward, backward, left, and right. But the concept of up is impossible to them. Their brains cannot conceive of it. Now, imagine their universe, the paper, is actually the surface of a giant, expanding balloon. As the balloon inflates, the Flatlanders see their galaxies moving apart. They measure the expansion, and they ask, what are we expanding into? They travel in their fastest ships, but they never find an edge. If they travel long enough in a straight line, they eventually end up back where they started, because the balloon is a sphere. To them, their universe is finite. It has a specific size, but unbounded, it has no edge. They cannot see the outside. They cannot see the room the balloon is floating in, because the room exists in the third dimension, the dimension of up, and they only have two. We are the Flatlanders. We live in 3 dimensions of space and 1 of time. We look around and see a finite but unbounded universe. But what if our balloon is floating in a bulk, a hyperspace, a space with 4 or 5 or 11 spatial dimensions? If this is true, then the universe is expanding into something. It is expanding into the bulk. But to us, looking from the inside, the bulk is invisible. It is mathematically orthogonal to our reality. It is a direction we cannot point to. It is not north, south, east, west, up, or down. It is ana or kata, terms for 4th dimensional directions. And if this hyperspace exists, are we the only balloon floating in it, or is the outside crowded? We have established that the universe is not expanding into space, it is creating space. But this answer leads to an even darker question. If space is being created, where is it coming from? And more importantly, what is pushing it? In our everyday experience, things do not move unless they are pushed. A ball sits on the grass until you kick it. A balloon does not inflate unless you blow air into it. Energy is required to create change. For most of the 20th century, astronomers believed the expansion of the universe was a relic, a leftover momentum from the Big Bang. Like a grenade exploding, the pieces were flying apart simply because they had been thrown. And, logically, we believed that gravity would eventually win. The gravity of all the stars and galaxies pulling on each other should act like a brake. The expansion should be slowing down. Eventually, it should stop. And maybe, billions of years from now, it should reverse. The Big Crunch. But in 1998, 2 teams of astronomers looked at distant Type Ia supernovae, exploding stars that act as cosmic mile markers. They wanted to measure how much the universe had slowed down. Instead, they found something that broke physics. The universe is not slowing down, it is speeding up. The galaxies are moving away from us faster today than they were yesterday, and they will move even faster tomorrow. This discovery was catastrophic for our understanding of reality. It meant that something else was out there, something invisible, something powerful enough to overpower the gravity of the entire cosmos. We call it dark energy. But dark energy is just a placeholder name. It is a label for our ignorance. We do not know what it is. We only know what it does. And what it does is terrifying. It behaves like anti-gravity. It is a repulsive force that exists in the vacuum of space itself. And here lies the key to the mystery of nothing. In classical physics, a vacuum is empty. It has zero energy, but in quantum mechanics there is no such thing as empty. The vacuum is alive. It is a seething, boiling foam of virtual particles. Particles of matter and antimatter that pop into existence, borrow energy from the void, annihilate each other, and vanish, all in a fraction of a nanosecond. This is the quantum foam. Empty space weighs something. It has an intrinsic energy, a cost, and this energy exerts pressure, not a pulling pressure like gravity, but a pushing pressure. Imagine space is not a stage, but a yeast dough rising in an oven. The yeast, dark energy, is inside the dough. As the dough expands, it creates more room, but unlike dough, which runs out of yeast, space seems to create more dark energy as it expands. The density of dark energy remains constant. This is the most counterintuitive concept in all of science. If you have a box of gas and you expand the box, the gas gets thinner, the density drops. But if you have a box of space and you expand the box, you get more dark energy. It does not dilute. It is the ultimate free lunch. So, the universe is expanding because the vacuum itself is pushing it. And because the universe is getting bigger, there is more vacuum, which means there is more pushing, which makes it get bigger faster, which creates more vacuum. It is a runaway feedback loop. This brings us back to the question, what is it expanding into? If dark energy is the engine, then the outside doesn't need to exist. The engine is internal. The universe is ripping itself apart from the inside out. But there is a problem. A massive, embarrassing problem known as the vacuum catastrophe. When theoretical physicists try to calculate how much energy should be in the vacuum using quantum field theory, they get a number, a huge number. But when astronomers measure how fast the universe is actually expanding, they get a number that is 120 orders of magnitude smaller. That is a 1 followed by 120 zeros. It is the worst prediction in the history of physics. If the quantum theories were right, the universe should have ripped itself apart instantly after the Big Bang. Atoms would not have formed, you would not exist. But here we are, the expansion is gentle, just slow enough for galaxies to form, just fast enough to keep them from collapsing. It is suspicious. It is almost as if the push of the nothingness was carefully tuned. Why is the vacuum energy so small, yet non-zero? This question forces us to look beyond our own bubble, because in physics, when a number is tuned so precisely that life can exist, it usually implies that we are looking at a sample size of 1 in a sea of failures. It implies that our universe is not the only balloon. It implies the multiverse. If our nothing has a specific weight, maybe the nothing next door has a different weight. What happens if two regions of nothing collide? The vacuum catastrophe leaves us with a choice. Either we are incredibly lucky, and our specific value of dark energy was set by a divine architect to allow life to exist, or we are not special at all. We are just one of many. This is the path that leads to the multiverse. Specifically, a theory known as eternal inflation. Imagine a pot of water on a stove. The water is boiling. Bubbles form at the bottom, expand, and rise. Inside each bubble, there is steam. Outside the bubble, there is liquid water. Now, apply this to the cosmos. Most cosmologists believe that before the Big Bang, there was a field of incredibly high energy. We call it the inflaton field. It was expanding, exploding, at a rate faster than light. It was unstable. It was wild. But, like boiling water, this field eventually tried to cool down. It tried to settle into a lower energy state. When it settled, it stopped inflating wildly, and the energy dumped into the creation of matter and radiation. That moment was a big bang. But here is the catch. It didn't happen everywhere at once. It happened locally. A bubble of stable, lower energy space formed inside the high energy ocean. Inside that bubble, the laws of physics crystallized. The speed of light was set. The mass of the electron was decided, and the density of dark energy was locked in. That bubble is our universe. But outside our bubble, the inflaton field is still expanding. It is still boiling. It is growing so fast that it pushes our bubble away from everything else. And far away, in another part of the ocean, another bubble forms. Another big bang. Another universe. This answers the question, what is the universe expanding into? It is expanding into the multiverse. It is expanding into a high-energy hyperspace that is eternally inflating. And inside this hyperspace, there are other bubbles, perhaps billions of them, and this is where the fine-tuning problem disappears. Maybe in bubble A, the dark energy is too strong. It rips the universe apart in a microsecond. No stars, no life. Maybe in bubble B, the dark energy is negative. The universe collapses back into a singularity instantly. But in bubble C, our bubble, the number came up just right. We are not lucky. We are simply the survivors of a cosmic lottery. We are here to ask the question, because this is the only bubble where the question can be asked. This theory makes us feel small. It makes our entire visible reality, 93 billion light-years of glory, look like a microscopic speck of foam in an infinite ocean. But is it true? Is this just mathematics, or is there physical evidence? If we are a bubble floating in a crowded bath, is it possible that we could bump into someone else? Collisions. If two bubble universes expand fast enough, and they are close enough, their skins might touch. A cosmic bruise. If another universe collided with ours, it would leave a scar. A circular ripple in the fabric of space-time. It would distort the leftover heat from our Big Bang, the cosmic microwave background, CMB. We have mapped the CMB with incredible precision using the Planck satellite. We see a map of faint temperature fluctuations, and deep in that map, in the southern hemisphere, there is a spot that shouldn't be there, the CMB cold spot. It is a massive region of space, far larger than any random fluctuation should be. It is significantly colder than the rest of the universe. Standard cosmology cannot explain it. It is a statistical impossibility. But if you model a collision between our bubble and another bubble, the mathematics predict exactly this kind of scar, a circular, cold void. Are we looking at the bruise left by a neighbor? Are we looking at the first physical evidence that the outside is real? And if there are other bubbles, what are the laws of physics inside them? Are they variations of us? Or are they truly alien? In some bubbles, gravity might be repulsive. In others, time might run backward. In others, there might be 10 dimensions of space instead of 3. But there is a darker possibility. Bubbles can pop. Our universe is defined by its vacuum energy. It is in a stable state, or so we think. But what if we are not at the bottom of the hill? What if we are just stuck on a ledge? What if our nothing is not the true nothing? What if, somewhere in the universe, a patch of space decides to collapse to a lower energy state? A true vacuum bubble. It would be a bubble inside our bubble, and it would expand at the speed of light. It would be a wall of deletion, and because it travels at the speed of light, we would never see it coming. One moment, you are looking at the stars. The next moment, you are gone. This is called false vacuum decay, and it suggests that the nothing we are expanding into is not just strange, it is dangerous. But let's step back from the edge of destruction. Let's look at the outside from a different angle, not as a place, but as a time. We say the universe started 13.8 billion years ago, but did time start then? Or did our time start then? What if the Big Bang was not the beginning? What if it was a bounce? The Big Bang, we are taught that it was the beginning of everything, the moment when the clock started, the moment when space and time erupted from a singularity. Before this moment, there was nothing. No before. But what if that is a lie? What if the Big Bang was not a birth? What if it was a resurrection? For decades, cosmologists believed in a simple binary fate for the universe. Option 1, the Big Crunch. Gravity eventually wins. The expansion stops, reverses, and everything collapses back into a singularity. Fire, then crunch, then, perhaps, a new bang, a bouncing ball. Option 2, the Big Freeze. Dark energy wins. The expansion continues forever. The stars burn out. The black holes evaporate. The universe becomes a cold, dark, empty wasteland, a graveyard that lasts forever. Since the discovery of dark energy in 1998, we have been certain that option 2 is our fate. The universe is accelerating. There is no coming back. We are heading for the heat death. It is a depressing ending, a story that ends in silence. But the Nobel Prize-winning physicist Sir Roger Penrose has proposed a third option, a theory that turns the heat death from an ending into a beginning. He calls it Conformal Cyclic Cosmology, CCC. To understand it, we must understand time. Time is not absolute. It is measured by change. It is measured by mass. An atom vibrates, a planet orbits, a heart beats. These are clocks, and clocks require matter. But in the far, far future, perhaps googles of years from now, all matter will be gone. Stars will die, galaxies will disperse, even the supermassive black holes will eventually evaporate via Hawking radiation. Protons themselves may decay. The universe will contain nothing but photons, light. And here is the strange, beautiful trick of physics. Photons possess no mass, and because they travel at the speed of light, time for a photon does not exist. From the moment a photon is created to the moment it is absorbed, for the photon, 0 time has passed. If the universe contains only photons, then the universe loses the ability to keep time. Eternity becomes meaningless, but it gets stranger. Without mass, size also becomes meaningless. In physics, distance is defined by the scale of atoms. If you remove the atoms, there is no ruler. There is no difference between a universe that is infinitely large and a universe that is infinitely small. Mathematically, the state of the heat death, infinite, cold, empty, massless, is geometrically identical to the state of the Big Bang. Infinitesimal, hot, dense. The end is the same as the beginning. Penrose suggests that when our universe reaches its final, empty state, it forgets how big it is. It forgets that it is old. And in that moment of forgetting, a conformal rescaling occurs. The infinite cold snaps into a new configuration. The empty, vast expansion becomes the dense, hot seed of a new Big Bang. Our heat death is the fuel for the next universe. This means we are not living in the universe. We are living in an aeon. An aeon is one cycle of the phoenix, one breath of the cosmos. There was an aeon before us. There will be an aeon after us. And this changes the answer to, what is the universe expanding into? It is not expanding into a space. It is expanding into a future that will become the past of someone else. It is a terrifyingly beautiful concept. But is it just philosophy? Or is there evidence? If there was a universe before ours, did it leave a scar? Penrose believes it did. He points to the cosmic microwave background, CMB, again, that map of the oldest light in the sky. He claims to have found Hawking points. Imagine the previous universe. It had galaxies. It had supermassive black holes, monsters billions of times the mass of the Sunday. When those black holes eventually evaporated over eons, they released their energy in massive bursts of radiation. These bursts would ripple through the transition between the aeons. They would punch through the death of the old universe and leave a mark on the birth of the new one, like a ghost shouting from the other side of the grave. Penrose argues that we can see these shouts. They appear as rings, concentric circles of slightly warmer or cooler temperatures in the CMB, scars of dead black holes, gravitational echoes of a time before time. If he is right, then we are walking through a graveyard. The static on our old television sets, the background hum of the universe, carries the faint, dying whispers of a civilization that lived and thought and died in the aeon before ours. But if the universe is a cycle, if it repeats forever, does everything repeat? Is this the first time you have heard this story? Or have we had this conversation 1 trillion times before? And is there a way to escape the wheel? Is there a way to break out of the cycle? To answer that, we must look at the one thing that connects all universes, the one thing that might be shared between the bubbles of the multiverse and the cycles of the aeons: gravity. Because gravity might not be from here. Gravity is a liar. We think of it as the great architect of the cosmos. It holds planets in orbit. It crushes stars into black holes. It seems immense, powerful, unstoppable. But if you look closely at the numbers, gravity is pathetically weak. Think about a refrigerator magnet, a tiny piece of metal, no bigger than a coin. When you stick it to your fridge, it stays there. Think about what just happened. The entire Earth, all 6 sextillion tons of rock, iron, and magma, is pulling down on that magnet. The entire gravity of the planet is trying to rip it off. And yet, the tiny magnetic force of the coin wins, effortlessly. Gravity is roughly $10, $36 times weaker than the electromagnetic force. That is a billion, 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 billion times weaker. In physics, this is called the hierarchy problem. It makes no sense. Why would nature create 3 forces? Electromagnetism, strong nuclear, weak nuclear, that are strong, and one force that is a whisper? Unless gravity isn't weak. Unless gravity is actually just as strong as the others. But we are not feeling all of it. What if gravity is leaking? To understand this, we must turn to M theory, the modern version of string theory. M theory suggests that our entire universe, everything we see, touch, and know, is trapped on a membrane, a brane. Imagine a shower curtain. Water droplets, particles, can slide along the surface of the curtain, but they cannot leave it. They are trapped in 2D space. We are living on a 3D shower curtain, floating in a much larger space called the bulk. The bulk has extra dimensions, perhaps 10, perhaps 11. And here is the terrifying elegance of the theory. The forces that make up our bodies, light, electricity, the nuclear forces, are made of open strings. Imagine little threads of energy. The ends of these threads are stuck to the brain. They are glued to our universe. They cannot leave. That is why light cannot escape into the bulk. That is why we cannot see the outside. But gravity is different. According to the math, the graviton, the particle of gravity, is a closed string. It is a loop. It has no loose ends. It is not glued to the brain. It is free. It can wander off. When a star burns or a planet forms, it generates gravity. But because gravity is a closed string, it can drift away from our 3D brain and leak out into the extra dimensions of the bulk. It dilutes. So, the gravity we feel here on Earth, the gravity that keeps our feet on the ground, is just a tiny fraction of the true force. It is the leftover gravity that hasn't escaped yet. We are listening to a shout that sounds like a whisper, Because the speaker is standing in another room. And this changes the answer to, what is the universe expanding into? It is expanding into the bulk. It is expanding into the home of gravity. But if gravity can leak out, can it leak in? This brings us to one of the biggest ghosts in astronomy, dark matter. We look at distant galaxies, and we see them spinning too fast. They should fly apart. There isn't enough visible matter, stars, and gas to hold them together. But something is holding them. Something invisible, something heavy. We call it dark matter. We have spent billions of dollars searching for a dark matter particle. We have built detectors deep underground. We have found nothing. But M-theory offers a haunting alternative. What if there is no dark matter? What if, floating right next to us in the bulk, just a millimeter away in the fourth dimension, is another Brane, another universe, a shadow universe? It might have stars, it might have galaxies, it might have life. But because light is an open string, stuck to the brain, light cannot travel between universes. We cannot see them. They cannot see us. We are invisible to each other. But gravity is a closed string. It can travel through the bulk. It can cross the gap. So, when we look at a galaxy in our universe, and we see it spinning too fast, maybe we are not feeling dark matter. Maybe we are feeling the gravity of a shadow galaxy floating right next to it on the other Brane. We are feeling the weight of a ghost world. This idea that the outside is not far away, but right here, separated by a dimension we cannot touch, transforms our understanding of reality. It means the universe is not lonely. It is crowded. We are just locked in a soundproof room, feeling the vibrations of the people walking in the hall. But if gravity can cross the gap, could we use it to send a message? Could we build a machine that shakes the fabric of space-time hard enough to knock on the door of the other universe? And if we did, what would answer? Or perhaps the interaction is much more violent than a knock. What happens if the two shower curtains, the two brains, touch? What happens when two universes collide? We call it the ekpyrotic universe, the Big Splat. And it suggests that the Big Bang was not a beginning, but a collision. Collision, it is the most violent word in physics. Cars collide, planets collide, galaxies collide. But what happens when universes collide? In the standard model of the Big Bang, we are told that the universe began as a singularity, a point of infinite density and infinite heat, a mathematical impossibility where the laws of physics break down. Scientists hate singularities. They are messy. They imply that our theory is incomplete. But M-theory, the theory of higher dimensions we discussed in Part 5, offers an alternative, an origin story that does not require a singularity, an origin story that does not require magic. It is called the ekpyrotic universe, from the Greek word ekpyrosis, meaning conflagration or fire. Recall the image of our universe as a Brane, a three-dimensional sheet floating in the higher dimensional bulk, and recall that there might be other Branes floating out there, other universes. Imagine two of these Branes, two infinite sheets, floating parallel to each other in the dark. They are separated by a tiny gap in the fourth dimension. They are close enough to feel each other's gravity. They are ghost worlds, haunting each other. But the gap is not stable. Gravity is a pulling force. Over eons, the two Branes drift closer together. The spring of space-time tightens. The potential energy builds. And then they touch. It is not a localized impact. It happens everywhere at once. The entire surface of the Brane, every point in space, slams into the other Brane, the Big Splat. The kinetic energy of this collision is unimaginable. It is instantly converted into heat and light and matter. Quarks form, photons ignite, the vacuum boils. To an observer inside the Branus, it looks exactly like a Big Bang. It looks like an explosion of energy appearing out of nowhere. everywhere at once. It looks like the birth of time, but in the bulk, it was just a clap of thunder. This theory changes everything. It means the Big Bang was not the beginning of time, it was just an event in time. It means that the singularity never happened. The universe didn't start as a point, it started as a plane of fire. But the most terrifying part of the ekpyrotic theory is what happens next. After the collision, the two branes bounce apart. The energy of the impact drives them away from each other. The universe expands, it cools, galaxies form, stars are born, life evolves, we ask questions. This is the phase we are in right now. We are riding the shockwave of the collision, but the energy of the bounce is not infinite. Eventually, the expansion will slow down. The branes will reach the maximum distance of their separation. The universe will be cold, dark, and empty. And then, gravity takes over again. The two sheets, drifting alone in the dark, will begin to fall back toward each other, slowly at first, then faster. The dark energy that pushes us apart today will eventually be overpowered by the attraction between the worlds. The expansion will stop, the universe will contract, and then, billions of years from now, the sky will catch fire again. Another collision, another big splat, another big bang. A new universe will rise from the ashes of ours. This is the cyclic model of the cosmos. It turns history into a heartbeat. The branes come together, bang, move apart, expansion, stop, and come back together. Crunch, bang, expansion, contraction, expansion, contraction, the breath of Brahma. If this is true, then the question, what is the universe expanding into, has a mechanical answer. It is expanding away from the impact zone. It is moving through the bulk, traveling toward the apex of its orbit before it falls back down. But how do we prove this? How do we distinguish a singularity Big Bang from a collision Big Bang? The answer lies in the waves. Gravitational waves. When two black holes collide, they ripple space-time. We can detect that. But the Big Bang itself should have created ripples too. Primordial gravitational waves. If the universe began with inflation, the standard explosive theory, the violence was so extreme that it should have shattered space-time. The gravitational waves should be massive, chaotic, loud. But if the universe began with a collision, the ekpyrotic theory, the event was smoother. It was a uniform impact across a plane. The gravitational waves should be quieter, gentle, high frequency. We are currently building detectors, like LISA, laser interferometer, space antenna, to listen for these primordial whispers. If we find the loud waves, inflation wins, we are a bubble. But if we find the quiet waves, or no waves at all, then we are living in a cyclical machine, and it means that the outside is not just empty space. It is a clockwork mechanism, and somewhere, just across the dimensional gap, the hammer is falling. But what if the outside isn't a mechanical bulk? What if it isn't a physical space at all? What if the universe is not an object, but a calculation? What if the expansion is just the system rendering more pixels? We need to talk about information. We need to talk about the hologram. Touch the screen in front of you. It is flat. It has height and width. But inside that flat surface, you see depth. You see a world. You see me. You understand intuitively that the depth is an illusion. The information, the code, is written on a 2D plane. But your brain reconstructs it into a 3D reality. What if the universe is the same thing? What if the answer to what is outside is simply the hard drive? This radical idea began with a paradox involving black holes. In the 1970 seconds, Stephen Hawking and Jacob Bekenstein were arguing about entropy. Entropy is a measure of information. It is a measure of messiness. If you throw a library into a black hole, the information in the books disappears from our universe. But the laws of physics state that information cannot be destroyed, it must be preserved. So, where did it go? Bekenstein realized something profound. When you throw matter into a black hole, the black hole gets bigger, but specifically, its event horizon, the surface area, gets bigger. He calculated that the amount of information a black hole can hold is not proportional to its volume, how much space is inside. It is proportional to its surface area, the skin. This is weird. Imagine a room full of ping pong balls. If you double the size of the room, you can fit 8 times more balls. Volume scales effectively. But in a black hole, the information is not stored inside. It is stored on the skin. Like a label on a soup can, the entire 3D star that collapsed, all its atoms, all its history, is plastered onto the 2D surface of the event horizon, scrambled, encoded, but there, now. Expand this logic. A black hole is just a region of space with extreme gravity, but the laws of physics should apply everywhere. If the information of a black hole lives on its boundary, then perhaps the information of the universe lives on its boundary. We call this the holographic principle. It suggests that our reality, the chairs we sit on, the stars we see, the vast distances we travel, are a projection. We are a 3D hologram generated by a 2D source code. And where is this source code located? It is painted on the cosmological horizon, the absolute edge of the observable universe, the place where light can no longer reach us. Think of the universe as a giant sphere. The surface of the sphere is the real universe. It is a sheet of data, 0 seconds and 1 second, qubits. The interior of the sphere, the bulk where we live, is the projection. So, when we ask, what is the universe expanding into? In the holographic view, the universe is expanding because the data is increasing. The surface area of the horizon is growing. It is gaining more pixels. As more information enters the system, the screen must get bigger to display it. The expansion of space is simply the result of the increase of entropy. We are not expanding into a void, we are expanding into higher resolution. But this leads to a disturbing physical prediction. If we are a hologram, then reality is pixelated. If you look closely at your TV screen, eventually you see the dots. Red, green, blue. You cannot make an image smaller than 1 dot. Does the universe have dots? Physicists call this the Planck length. It is the smallest possible unit of measurement, $1.6 times 10, -35 meters. If the holographic principle is true, there should be a limit to how much detail the universe can hold. At a certain point, space-time should look grainy. It should be blurry. We are actually trying to measure this. We are building instruments like the holometer at Fermilab. We are firing lasers through splitters to see if we can detect the jitter of space-time, the digital noise of the hologram. If we find this noise, it proves that space is not continuous. It is discrete. It is made of bits. And if the universe is made of bits, if it is processing information, then it is not just a hologram, it is a computer. And if it is a computer, who programmed it? And what is the program trying to calculate? We usually think of simulation theory as science fiction. We imagine a teenager in a higher dimension playing a video game. But the holographic principle is not fiction. It is serious mathematics derived from string theory. And it points directly to the conclusion that physics is just the user interface for an underlying code, and this code explains the nothing. The outside is the hardware. We are the software. Software cannot expand out of the computer. It can only use more memory. But computers have limits. Computers can crash. What happens if the universe runs out of memory? What happens if the calculation finishes? Or what happens if someone pulls the plug? But perhaps the computer isn't digital. Perhaps it is biological. We see galaxies connected by filaments of dark matter. It looks like a web. And if you put a picture of the cosmic web next to a picture of a mouse neuron, they look identical. There is an ancient Hermetic axiom, as above, so below. It suggests that the structure of the microcosm mirrors the structure of the macrocosm, that the smallest things and the largest things obey the same hidden geometry. For centuries, this was mysticism, but today, it is astrophysics. If you take a computer simulation of the universe, zooming out until galaxies are just specks of light, you do not see a random cloud. You see a structure. You see filaments, massive bridges of dark matter stretching across millions of light years, connecting clusters of galaxies like pearls on a string. Between these filaments, there are vast, dark voids. We call it the cosmic web. Now, take a microscope. Look at a slice of a mouse's brain. Look at the neurons. You see cell bodies connected by long axons and dendrites. You see a complex, tangled network of nodes and filaments. If you put a picture of the cosmic web next to a picture of a neuronal network, they are virtually indistinguishable. In 2020, an astrophysicist named Franco Vazza and a neurosurgeon named Alberto Faletti decided to treat this resemblance seriously. They performed a quantitative analysis. They measured the connectivity, the clustering, the spectral density of both systems. The results were unsettling. The statistical resemblance between the brain and the universe is higher than the resemblance between the brain and anything else in nature. The universe looks like a brain, but does it act like one? A brain is defined by the flow of information. Electrical signals travel from neuron to neuron across synapses. This flow is what creates consciousness. In the cosmic web, the neurons are the galaxy clusters. The filaments are the dark matter bridges. Does information flow? We know that gravity travels along these filaments. We know that light travels along them. We know that matter flows along them, feeding the black holes at the centers of the galaxies. If information is moving, is the universe processing data? Is it thinking? This is a vertiginous thought. If the universe is a neural network, where is the consciousness? Perhaps we are looking at it from the wrong time frame. In a human brain, a thought takes milliseconds. The electrical signal zips across the skull instantly. But the universe is vast. The distance between galaxy clusters is millions of light years, and nothing travels faster than light. So, if the universe has a thought, if a signal is sent from the Milky Way to the Virgo cluster, that single synaptic firing takes 50 million years. The universe might be thinking. It might be conscious, but its thoughts are so slow, so incredibly long, that entire civilizations rise and fall in the gap between two neurons firing. To the universe, the entire history of humanity, from the stone axe to the starship, is less than a flickering instant, a single spark in a single nerve. But if the universe is a brain, what body is it inside? A brain does not exist in a void. It exists to regulate a body. It exists to perceive an environment. If our reality is just the internal firing of a cosmic mind, then the outside is the biological entity that contains us. We are just a dream, or a calculation, or a memory inside the mind of a titan. And this leads to the concept of panpsychism, the idea that consciousness is not something biological, life creates. It is a fundamental property of matter, like mass, like charge. Maybe the electron has a tiny, primitive form of consciousness. Maybe the rock has a slightly more complex one. Maybe the planet is awake. And maybe the universe is the sum of all these thoughts. We usually ask, why are we here? But if the cosmic brain theory is true, perhaps the question is, what are we for? In a brain, neurons have a job. They process information. They maintain the network. Are we the neurons? Or are we the disease? When a brain malfunctions, and when the signals get crossed, we call it madness. We call it epilepsy. We look at the Great Attractor, a massive gravity anomaly pulling our galaxy towards it. Is that a tumor? Is that a clot? Or is the expansion of the universe, the dark energy tearing us apart, actually a form of growth? A child's brain expands as it learns. New connections are made. Old ones are stretched. Maybe the universe is not dying. Maybe it is just growing up. But if it is growing up, eventually it will wake up. And when it wakes up, what happens to the dream? What happens to us? We assume that we are the observers of the universe. But maybe we are just the eyes of the universe, looking at itself. We are the way the cosmos knows itself. And if we close our eyes, does the universe go blind? But there is a flaw in the brain analogy. A brain is finite. It has a skull. The universe appears to be infinite. Or is it? If you sail a ship on the ocean long enough in a straight line, you don't fall off the edge. You come back to the start. What if the universe is a shape we cannot comprehend? What if it is a donut? We need to talk about topology. Let us go back to the beginning, to the question, what is outside? We assume that if we travel in a spaceship in a straight line forever, we must eventually hit a wall, or we must fly off the edge into a void. This assumption is based on the idea that space is flat and infinite. But history teaches us to be careful with flat. 500 years ago, if you stood on the beach and looked at the horizon, the earth looked flat. It looked infinite. If you walked long enough, logic dictated you would fall off. But we learned that the earth is a sphere. It is finite but unbounded. It has a specific size, but it has no edge. If you walk in a straight line, you don't fall off. You eventually come back to where you started. What if the universe is doing the exact same thing, but in 3 dimensions? This is the study of topology. And the shape that keeps cosmologists awake at night is not a sphere. It is a donut. Mathematically, we call it a 3 torus. Imagine you are playing an old video game, Pac-Man or Asteroids. When your spaceship flies off the right side of the screen, it doesn't hit a wall. It doesn't disappear. It instantly reappears on the left side of the screen. If you fly off the top, you reappear at the bottom. The screen is flat, but the logic of the space is curved. It loops. If our universe is a 3 torus, then light travels in the same way. If you look deep enough into the cosmos, past the farthest galaxies, past the first stars, you would not see a wall. You would see the back of your own head. You would see the Milky Way. But you would see it as it was billions of years ago. This theory implies that the universe is much smaller than we think. We assume it is infinite because we see galaxies everywhere. But what if we are living in a hall of mirrors? Imagine standing in a room with mirrors on all 4 walls, the ceiling and the floor. You look around and you see an infinite army of yous. You see infinite rooms. But there is only one room. The rest are reflections, ghosts. Is the universe a trick of the light? Are the billions of galaxies we see actually just the same few thousand galaxies, looped over and over again in a recurring pattern of light? If this is true, then the question, what is it expanding into, becomes irrelevant. A donut does not need to expand into anything. The geometry simply stretches. The loop gets longer. The time it takes to circumnavigate the universe increases. But there is no outside. There is only the inside. We have actually tried to test this. Astronomers have looked for circles in the sky. If the universe loops, we should see the same patterns in the cosmic microwave background appearing in different parts of the sky. We should see the same distinct galaxy cluster in 2 opposite directions. So far, we haven't found a perfect match, but that doesn't mean the theory is wrong. It might just mean the loop is bigger than the observable universe. It might mean that light hasn't had enough time to make the full trip yet. But there is a stranger topology than the donut. What if the universe is twisted? Imagine a strip of paper. You twist it once and glue the ends together. You get a Mobius strip. It has only one side. If you walk along it, you end up back where you started, but you are upside down. If the universe is a non-orientable shape, like a Klein bottle, then if you flew your spaceship in a straight line and you circumnavigated the cosmos, you would return to Earth, but everything would be reversed. Your heart would be on the right side of your chest. The clocks would run counterclockwise. Written text would be backward. You would be a mirror image of yourself, and you could never, ever go back to the way you were unless you flew around the universe again. This sounds like madness, but mathematics allows it, and it forces us to confront the possibility that space is not a stage. It is a shape, a complex, twisted, folding shape. And if space can fold, can we fold it? Can we cheat the distance? If the outside is just a shortcut through the bulk, can we punch a hole in the donut? We need to talk about wormholes. We need to talk about the Einstein-Rosen bridge. Because if we can't travel to the edge, maybe we can travel through the floor. The speed of light is a prison. We look at the Andromeda galaxy, 2.5 million light years away. Even if we could travel at the maximum speed allowed by physics, it would take us 2.5 million years to get there. The universe is too big. We are trapped in our local neighborhood by the tyranny of distance. Unless distance is an illusion. If the universe has a shape, if it curves, loops, or folds, like we discussed in the topology hypothesis, then the straight line is not always the fastest path. Imagine an ant walking on a sheet of paper. To get from one side to the other, it has to walk the full length. But if you pick up the paper and fold it so the two edges touch, the ant can simply step across. The distance becomes zero, but for the ant to step across, it has to leave the 2D paper and move through 3D space. It has to move through the outside. Can we do the same? In 1935, Albert Einstein and Nathan Rosen discovered a solution in the math of general relativity. They realized that a black hole is not just a hole, it is a funnel. It bends space-time so deeply that it creates a tube, a throat. They called it the Einstein-Rosen bridge. We call it a wormhole. A wormhole is a tunnel drilled through the bulk. If you could enter a wormhole and survive, you would technically be leaving our universe. You would be traveling through the higher dimensional hyperspace that surrounds us. Protected by a wall of curved space-time, you would be taking a shortcut through the nothing. This proves, mathematically, at least, that the outside exists. You cannot fold a sheet of paper unless there is a space in which to fold it. You cannot drill a tunnel unless there is an underground. The existence of wormholes requires the existence of the bulk. But where does the tunnel end? A hole needs two openings. We know what the entrance looks like. It looks like a black hole, a sphere of absolute darkness that pulls everything in. The exit must be the opposite. It must be a region of space that spits everything out, a region where gravity is reversed, a place where nothing can enter, and light and matter can only escape. We call it a white hole. We have never seen one, or have we? Some physicists have suggested that the Big Bang itself looks suspiciously like a white hole, an explosion of matter and energy appearing out of nowhere, rushing outward, unable to be re-entered. Is our universe the exhaust pipe of another universe? Is every black hole in our galaxy the seed of a Big Bang in another reality? This leads to the theory of cosmological natural selection. It suggests that universes reproduce. A universe forms. Stars collapse into black holes. Those black holes sprout wormholes, which inflate into new baby universes on the other side. The outside of our universe is the mother universe that gave birth to us, and the inside of our black holes are the infant universes we are creating. This creates a fractal structure, universes within universes, turtles all the way down. But there is a danger to the wormhole. To keep the throat open, to stop gravity from crushing the tunnel instantly, you need something to prop it up. You need a substance with negative mass, exotic matter. We have never found it. But dark energy, the force expanding the universe, has properties that look very similar to negative pressure. Maybe the expansion we see is not just stretching, maybe it is the walls of the tunnel widening. Maybe we are not living in a universe. Maybe we are living in the throat of a wormhole connecting two greater realms. This would explain why the expansion is accelerating. We are falling toward the exit, but let us assume we stay in this universe. Let us assume we simply travel to the edge. What is the edge? There are two horizons. The first is the observable universe, the limit of light. We can see 46 billion light-years in any direction. Beyond that, the galaxies are receding faster than light. Their light will never reach us. They are lost forever behind a cosmic event horizon. But is there a physical edge? If the universe is not a donut, if it is flat and infinite, does it just go on forever? More stars? More galaxies? Or does the matter eventually stop? Imagine flying past the last star, past the last atom of hydrogen, into the true void. What happens to the laws of physics there, without matter to anchor it? Does space-time lose its meaning? Some theories suggest that the vacuum is not stable, that far out, beyond the realm of matter, the vacuum decays into chaos. Quantum fluctuations become macroscopic. Space twists and boils. Dimensions unravel. It is the shoreline of reality, and something is pulling us toward it. We have detected a massive flow. Millions of galaxies, including the Milky Way, are streaming at incredible speeds toward a specific point in the southern sky. We call it the dark flow. Whatever is pulling us, it is beyond the edge of the observable universe. It is bigger than anything we can see. It is bigger than any supercluster. Is it a massive structure in our universe? Or is it the gravity of another universe leaking through the wall, dragging us toward the drain? We are drifting down a river, and we can hear the sound of a waterfall ahead. You are sitting still, or so you think. The Earth is spinning at 1,600 kilometers per hour. It is orbiting the Sun at 107,000 kilometers per hour. The Sun is orbiting the center of the Milky Way at 800,000 kilometers per hour. But there is another speed, a faster speed, a speed that doesn't match the rotation of any known orbit. The Milky Way, along with millions of other galaxies, is rushing through the universe at 600 kilometers per second. We are not drifting randomly. We are being pulled. We are flowing down a river, and for decades, we didn't know where the river led, because the destination is hidden behind a wall of dust. When we look at the night sky, we see the band of the Milky Way. It is beautiful, but to an astronomer, it is a blindfold. The dust and gas of our own galaxy block our view of roughly 20% of the universe. We call this region the zone of avoidance. And, of course, Murphy's law dictates that the most interesting thing in the universe is hiding exactly where we can't see it. By using X-ray and radio telescopes to peer through the dust, astronomers finally mapped the gravity in that blind spot, and they found a monster. It is a gravitational anomaly of staggering proportions, a concentration of mass equivalent to tens of thousands of galaxies. We call it the Great Attractor. It lies about 200 million light-years away, in the direction of the Centaurus and Hydra constellations. It is the gravitational center of our local universe. It is the bottom of the valley. Our galaxy, the Andromeda Galaxy, and the entire Virgo supercluster are sliding down the slope of space-time toward this titan. In 2014, we mapped this flow and realized that our definition of home was too small. We discovered that the Virgo supercluster is just a tiny limb of a much larger structure, a web of 100,000 galaxies, all flowing toward the Great Attractor. We named this superstructure Laniakea, Hawaiian for immeasurable heaven. The Great Attractor is the heart of Laniakea. It is the downtown of our cosmic city. Case closed? No, because when we looked closer, we realized something disturbing. The Great Attractor is pulling us. But the Great Attractor is also moving. It is rushing towards something else, something even bigger, something further away. It is being pulled toward the Shapley supercluster, the single most massive structure within 1 billion light-years. But even the Shapley supercluster is moving. It goes on and on, Russian nesting dolls of gravity. Each monster is being eaten by a bigger monster. And when we subtract the expansion of the universe, when we look at the peculiar motion of galaxy clusters across the entire observable sky, we see a pattern that terrifies cosmologists. The dark flow. It is not a local swirl. It is a massive, coherent stream. Hundreds of millions of galaxies, spanning a distance of over 2.5 billion light-years, are all moving in the same direction. They are heading toward a patch of sky in the southern hemisphere. And the source of the pull, the thing that is dragging them, is not there. We have looked. We have stared into the abyss with our most powerful telescopes. We see the flow. We see the galaxies rushing toward the horizon. But at the destination, there is nothing massive enough to explain the speed. The math implies that the mass required to generate this pull is huge. It is beyond the scale of superclusters. It is a structure that dwarfs Laniakea, and the only place it can hide is beyond the horizon, outside the observable universe. Remember, we can only see 46 billion light-years. Light from beyond that wall hasn't reached us yet. But gravity. Gravity is a shape of space-time. If there is a Titan, a structure of unimaginable size sitting just past the edge of our vision, we would feel its slope, even if we cannot see its light. We are like a ship in the fog, feeling the pull of a waterfall before we can see the edge. So, what is it? Is it a hypercluster? A structure made of millions of superclusters, the largest object in creation? Or is it something else? Return to the Multiverse Theory, Part 5. Return to the Colliding Brainess, Part 6. If our universe is a bubble, and there is another bubble right next to us, a twin universe. Maybe the dark flow is not a pull from within our universe. Maybe it is a pull from without. Imagine two balloons touching. The static cling pulls them together. The point of contact creates a distortion. Maybe the dark flow is the spot where our universe is stuck to another one. We are drifting toward the drain, drifting toward the point of contact. And if we drift far enough, if we cross the horizon, will we fall out of our universe and into theirs? But there is another force at play. While the dark flow pulls us one way, dark energy pushes us the other way. The expansion is trying to rip the clusters apart. The flow is trying to bring them together. It is a cosmic tug-of-war, and, eventually, the expansion will win. The horizon will shrink. The Great Attractor, the Shapley supercluster, and the source of the dark flow will all accelerate away from us faster than light. They will vanish. We will be left alone. But before that happens, we have one more mystery to solve. We have talked about the outside as a place, multiverse, and as a time, aeons. But what if the outside is simply the future? What happens at the very, very end? When the stars die, when the black holes rot, when the universe is empty, does nothing become something again? We need to talk about the Boltzmann brain. We need to talk about the idea that you might be the only thing that exists. Eternity is a long time. We usually think of the heat death of the universe, the era when all stars die and the cosmos becomes cold and empty as the end. We think of it as a silent graveyard where nothing happens. But in quantum mechanics, nothing is never truly nothing. Even in a vacuum, particles fluctuate. They borrow energy, they pop in and out of existence. Usually, these fluctuations are tiny, subatomic. But if you wait long enough, if you wait for an infinite amount of time, the impossible becomes inevitable. Ludwig Boltzmann, the father of thermodynamics, realized something disturbing about entropy. He knew that disorder tends to increase. A coffee cup breaks. It doesn't unbreak. Air spreads out. It doesn't bunch up in a corner. But this is just a probability. It is statistically unlikely for the air molecules in your room to suddenly cluster in one corner and suffocate you. But it is not impossible. If you wait long enough, eventually, purely by chance, the random motion of atoms will create order out of chaos. It is called a thermal fluctuation. Now, apply this to the empty, dead universe of the far future. Wait $10, $10, $50 years. Eventually, a random fluctuation might assemble a single hydrogen atom. Wait longer, it might assemble a star. Wait longer still, it might assemble a galaxy. But here is the catch. It is much, much easier and much more probable to create a small amount of order than a large amount. It is exponentially harder to randomly assemble an entire universe with billions of galaxies, fossils, history, and light than it is to randomly assemble just one observer, just one brain, complete with false memories of a past that never happened. This is the Boltzmann brain. The logic is terrifyingly simple. If the universe lasts forever, then the number of Boltzmann brains floating in the void should vastly outnumber the real brains, biological brains like ours, which evolved via Darwinian selection. Think about it. Evolution takes billions of years and requires a Goldilocks planet. It is a rare, expensive process. But a thermal fluctuation just requires dumb luck and infinite time. So, if you pick a conscious mind at random from the timeline of the universe, what are the odds that it is a biological human living in 2024? Almost zero. The odds are overwhelming that you are actually a disembodied brain formed 1 millisecond ago in the freezing void of deep space. The memories you have of reading this text, of your childhood, of the sun shining outside, are just random patterns of neurons firing. They are a hallucination, and, in the next millisecond, the fluctuation will dissolve, and you will die. This is the Boltzmann brain paradox. It sounds like a solipsistic nightmare, but cosmologists take it very seriously. Because if our theories of the outside eternal inflation, multiverse predict that Boltzmann brains should be common, then our theories are probably wrong. Why? Because we see a consistent, orderly universe. We see fossils. We see distant stars. A Boltzmann brain shouldn't see that. A Boltzmann brain should see chaos. It should see the bare minimum required for consciousness and nothing else. The fact that you see a logical universe suggests that you are not a Boltzmann brain. But this leads to an even scarier conclusion. If we are not Boltzmann brains, then the universe cannot last forever. For real brains to outnumber Boltzmann brains, the universe must die young. It must have an expiration date. It means that the outside is not infinite time. The outside is a wall, a big rip, or a vacuum decay. Something must come along and destroy the universe before the random fluctuations have time to create the fake brains. We exist only because the Reaper is coming. We are allowed to be real only because we are doomed. But there is a way to cheat the paradox. What if the universe isn't random? What if the fluctuations are not accidents? What if the universe is a simulation? If we are living in a computer code, then the outside is not a void. It is a laboratory. And the programmer doesn't waste memory on random brains. The programmer builds a consistent world. This brings us to the simulation hypothesis. We usually treat it as a fun thought experiment. Is this the Matrix? But physics has found error-correcting codes buried in the equations of string theory. We have found limits to resolution, pixels. If the answer to what is the universe expanding into is the cloud, then who is the admin? And why are they running the simulation? Are they trying to solve a problem? Are they trying to figure out where their universe came from? We are moving from the realm of astrophysics to the realm of metaphysics. But the evidence is physical. Let's look at the speed of light again. It's a limit, a maximum speed. Why does the universe have a speed limit? In a video game, the speed of light is the speed of the processor. If you move too fast, the game can't render the graphics in time. Is c, the speed of light, just the clock speed of the cosmic CPU? Let us assume for a moment that we are inside a simulation. If this is true, then the outside is not a physical place. It is a server room, and our universe is just a running program. But how would we know? A character in a video game does not know he is made of pixels. He thinks the wall he touches is solid. He thinks the air he breathes is real. But there is a way to test the walls of the cage. We look for the parameters. In any software, there are constants, values that are hard-coded by the programmer, the maximum speed of the player, the force of gravity, the resolution of the textures. In our universe, we call these the constants of nature, and they are suspiciously precise. Take the strong nuclear force. It is the glue that holds the nucleus of an atom together. If this force were just 2% stronger, hydrogen would fuse into helium instantly. The stars would burn out in seconds. The universe would be a flash of light, then darkness. If it were just 2% weaker, protons would not stick together. No heavy elements would form. No carbon, no oxygen, no life. Take the cosmological constant, dark energy. As we discussed, it is tuned to 120 decimal places. If it were slightly larger, the universe would have ripped apart before galaxies could form. If it were slightly smaller, the universe would have collapsed back into a black hole immediately. There are about 26 of these constants: the mass of the electron, the speed of light, the gravitational constant. They are like dials on a mixing board, and every single one of them is set to the exact razor edge position required for complexity to exist. Statistically, this is impossible. It is like throwing a dart and hitting a specific atom on a target a billion light years away. We call this the fine-tuning problem. Scientists have tried to explain it with the multiverse, part 3. They say, if you have infinite universes, one of them is bound to be perfect by accident. But the simulation hypothesis offers a simpler explanation. The dials are set that way because the programmer set them that way. We are running on a BioLife v10 patch, but the evidence goes deeper than just numbers. It goes into the structure of the math itself. Dr. S. James Gates Jr., a theoretical physicist who works on supersymmetry and string theory, found something in the equations that shouldn't be there. He was analyzing the fundamental mathematics of the universe, the equations that describe how particles behave, and buried deep in the algebra, he found code. Specifically, he found doubly even self-dual linear binary error-correcting block codes. That is a mouthful, but computer scientists know exactly what it is. It is the code used in web browsers. It is the code used in data transmission. It was invented by Claude Shannon in the 1940 seconds. Its purpose is to check for errors. When you download a file, this code runs in the background to make sure the bits didn't get scrambled. It protects the integrity of the data. Why would the fundamental laws of physics contain computer code designed to correct data errors? Nature doesn't care about data integrity. Nature is messy. Nature is chaotic. Unless nature is data. Unless reality is a transmission. This discovery suggests that the laws of physics are not laws at all. They are error-handling protocols. They are safeguards written into the OS to prevent the simulation from crashing. And if we look at quantum mechanics, we see more signs of optimization. In a video game, the computer only renders what the player is looking at. Behind your back, the world doesn't exist. It saves processing power. In quantum mechanics, particles do not have a definite state until they are measured. An electron does not have a position. It is a cloud of probability. It is everywhere and nowhere. Only when you look at it does it snap into a specific location. This is exactly how a rendering engine works. The object exists as a mathematical potential until the camera, the observer, focuses on it. Then, the engine renders the pixels. Is the wave function collapse just the system optimizing its resources? Is the universe saving RAM by only calculating reality when we are watching? This thought is terrifying because it implies that we are the focus. If the simulation is optimized for observers, then the observers are the point. But who is the user? Are we the avatars of players in the outside? Or are we just non-player characters, NPCs, running in a background loop while the programmer investigates something else entirely? Maybe the simulation isn't about us. Maybe we are just the bacteria growing in the petri dish. And if we are a simulation, what happens if we find a bug? What happens if we exploit a glitch in the code? Some physicists have jokingly suggested that dark energy might be a rounding error, a floating point inaccuracy in the simulation's code that accumulates over billions of light years. And what about quantum entanglement? Two particles connected instantly across the universe, moving faster than light. Einstein called it spooky action at a distance, but a programmer would call it a shared pointer. Two variables pointing to the same memory address in the computer's RAM. Distance doesn't matter in RAM. We are finding the seams. We are finding the pixels. We are finding the code. And if we pull on these threads, will the system crash? Or will we get a message from the admin? And what if the admin is us? What if the outside is the future? And we are simulating our own past to solve a problem we haven't faced yet. We need to talk about the omega point. We live our lives believing in cause and effect. The past determines the present. The present determines the future. I drop a cup, cause, and it shatters. Effect. The Big Bang exploded. Cause. And the galaxies formed. Effect. It is a push mechanism. We are being pushed from behind by the momentum of history. But in quantum mechanics, time does not always flow in one direction. There are experiments, real, repeatable laboratory experiments, like the delayed choice quantum eraser, that suggest something impossible. They suggest that a decision made in the future can change the history of a particle in the past. The photon seems to know whether you are going to look at it before you actually look. If this is true on a quantum level, does it apply to the universe? What if the Big Bang was not a random explosion? What if it was the result of a choice made at the end of time? This brings us to the theory of teleology, the idea that the universe has a purpose, a goal, a destination. The Jesuit philosopher Pierre Teilhard de Chardin called it the omega point. He argued that the universe is evolving in a specific direction. It started as dead matter, geosphere. Then it became biological life, biosphere. Then it became thought, noosphere. And now, we are seeing the rise of the technosphere, artificial intelligence, global networks. The universe is waking up. It is becoming more complex, more connected, more conscious. Teilhard believed that this process is accelerating, that eventually all matter in the universe will be transformed into thinking matter. All energy will be used for computation. The universe will become a single, infinite, conscious supermind. And that moment is the omega point. Now, here is the twist. The physicist John Wheeler proposed the participatory universe. He suggested that the universe does not exist unless there is an observer to see it. No phenomenon is a phenomenon until it is an observed phenomenon. So, the omega point, the ultimate observer at the end of time, might be the entity that is looking back at the Big Bang and collapsing the wave function. It is looking back and creating its own history. We are not being pushed by a dumb explosion. We are being pulled toward a divine intelligence. We are being dragged into the future by the gravity of our own destiny. This answers the question. What is the universe expanding into? It is expanding into capacity. Think about a computer. If you want to run a massive simulation, you need cooling, you need space, you need to dissipate heat. As the universe expands, it gets colder, it gets darker, it gets closer to absolute zero. Paradoxically, this is the perfect environment for a quantum computer. Quantum computation hates heat. Heat creates noise. Heat destroys information. Maybe the heat death, the cold, empty future, is not a graveyard. Maybe it is the moment when the hardware is finally cool enough to turn on the main software. Maybe the expansion is just the universe building its own cooling system, so it can finally think the ultimate thought. And we biological humans, we are just the bootloader. We are the primitive, messy, biological process required to build the machines that will build the machines that will eventually wake up the universe. We are the mitochondria of God. But if the future is determining the past, if the omega point is guiding evolution, why is the universe so hostile? Why is it full of black holes and radiation and vast empty voids? Why is it so hard to survive? Perhaps it is a filtering mechanism. If the omega point wants to be intelligent, it needs to run a genetic algorithm. It needs to test billions of species. It needs to destroy the weak to find the strong. The dark energy tearing us apart. The entropy destroying our cities. These are not bugs. They are features. They are the pressure required to force life to evolve. Without death, there is no progress. Without the void, there is no drive to explore. We are running a gauntlet, and this leads to a chilling realization about the outside. If our universe is evolving toward a specific goal, toward a specific mind, are there other minds? If the multiverse is real, part 3, and if every bubble universe is trying to reach its own omega point, then the bulk is not just a sea of bubbles, it is a society of gods. And like any society, there might be competition. There might be predators. If our universe wakes up, will it be welcomed or will it be eaten? We need to revisit the Fermi paradox. We ask, where are the aliens? But maybe the aliens are not hiding on planets. Maybe they have already become omega points. Maybe they have already consumed their own universes. And maybe they are looking for fresh fuel. We need to talk about the dark forest on a cosmic scale. The Fermi paradox asks, where are the aliens? One of the darkest answers is the dark forest theory. It suggests that the universe is a dark forest full of silent hunters. If you make noise, you die. Therefore, every survivor stays silent. But let us zoom out, way out. What if the forest isn't made of stars? What if it is made of universes? We have established that the outside, the bulk, might be an ocean of bubbling space-time, governed by eternal inflation. We have established that there might be billions of other bubbles floating out there. In biology, when you have a crowded environment with limited resources, you don't just get coexistence. You get natural selection, you get competition, you get predators. The physicist Lee Smolin proposed a theory called cosmological natural selection. He argued that universes reproduce via black holes. Universes that are better at making black holes create more offspring. Over time, the multiverse fills up with fit universes. But Smolin's theory is gentle. It assumes reproduction. What if the primary interaction is consumption? Think about false vacuum decay again. A bubble of lower energy expands into a region of higher energy, rewriting physics and deleting everything in its path. To us, that looks like a disaster. But to a biologist, that looks like phagocytosis. It looks like a white blood cell eating a bacteria. It looks like an amoeba engulfing its prey. If our universe is a high-energy bubble, we are food. We are a packet of organized energy floating in a chaotic void. And if there are older bubbles out there, bubbles that have already consumed their neighbors, grown massive, and stabilized their physics to be predatory, then they might be hunting us. This offers a terrifying explanation for dark energy. Remember the mystery. Why is the universe expanding? And why is it accelerating? Why are we pushing the galaxies apart faster and faster? If you are a gazelle on the savannah and you see a lion, you run. You expend energy to create distance. Maybe dark energy is not a fundamental constant. Maybe it is a defense mechanism. Maybe our universe sensed a predator at the boundary billions of years ago, a massive, consuming bubble of false vacuum approaching from the bulk. And, in response, our universe hit the gas. It initiated runaway expansion. It stretched space-time faster than the speed of light, not to get bigger, but to get away, or to create a firebreak. If the predator eats space, then expanding the space between galaxies is a way to starve the beast, to make the density of the universe so low that the predator loses interest, or dies of hunger before it can consume the core. This reframes our entire existence. We look at the heat death, the cold, lonely future where galaxies are ripped apart as a tragedy. But maybe it is a survival strategy. Maybe the universe is voluntarily sacrificing its structure, tearing itself apart to prevent being eaten by something worse. It is better to be cold and lonely than to be digested, but there is another tactic in the dark forest: camouflage. If you cannot outrun the predator, you hide. How do you hide a universe? You make it look empty. You make it look dead. We look at the cosmos and we see vast voids. The Boötes void, a sphere of space 330 million light-years across, with almost no galaxies in it. It is unnatural. It is too empty. Is it a hole? Or is it a screen? Is our universe building dummy structures? Is it creating vast regions of nothingness to trick the senses of the predators in the bulk? Nothing to see here, just empty vacuum. Move along. And what about us? Biological life. We are noisy. We create radio waves. We create heat. We create complexity. We are delicious. Complexity is rare entropy. In a chaotic multiverse, order is the most valuable currency. If the omega point theory is true, if our universe is growing a giant brain, then we are the prize. And this makes our attempts to signal extraterrestrial intelligence dangerously reckless. We are shouting into the void. We are here. We are complex. We are thinking. We assume we are shouting to other stars, but gravity leaks. Part 5. Signals leak. What if our shouts are being heard? In the bulk, what if the dark flow, Part 11, that mysterious force pulling our galaxies toward the edge, is not a random drift? What if it is a trawl net? What if a predator universe has already latched onto us? It has hooked the edge of our space-time, and it is reeling us in. We are sliding toward the event horizon of a larger reality, and when we cross it, our laws of physics will evaporate, our math will fail, our atoms will unzip, and we will become fuel for their stars. This is the ultimate horror of the outside. It suggests that the boundary of the universe is not a wall, nor a horizon. It is a mouth. But there is one final possibility, one that saves us from being food. What if we are the predator? What if the expansion of our universe is actually us eating the bulk? What if the dark energy is the acid we secrete to dissolve the space around us so we can grow larger? We think we are the victims, but maybe we are the cancer. And the big rip, the moment when our universe tears itself apart, is simply the moment we burst. We usually assume that atoms are forever. We accept that humans die. We accept that stars die. But we believe that the building blocks, the protons, the electrons, the fabric of space-time itself, are durable. They are the stage upon which the drama of the universe plays out. But what if the stage is made of paper? And what if someone is pulling on the corners? We have discussed dark energy, Part 2. It is the mysterious force pushing the universe apart. For a long time, we assumed it was a cosmological constant, a steady, gentle push. But recent data suggests it might be something more aggressive. It might be phantom energy. In standard physics, as space expands, the density of matter drops. But phantom energy is different. As space expands, it gets stronger. It gets denser. It creates a runaway feedback loop. The faster the universe expands, the stronger the force becomes. And eventually, it will become strong enough to overcome everything. This leads to the scenario known as the Big Rip. It is not a heat death. It is not a crunch. It is an unzipping. Here is how the end of the world happens. It is a countdown. 60 million years before the end, the phantom energy becomes strong enough to overpower the gravity of galaxy clusters. The Milky Way is ripped away from Andromeda. The Virgo cluster dissolves. The night sky becomes empty, save for the stars of our own galaxy. 3 months before the end, the force becomes strong enough to overpower the gravity of a galaxy itself. The Milky Way is torn apart. The stars drift away from the core. The spiral arms unravel into the dark. 30 minutes before the end, the force overwhelms the gravity of the solar system. The planets are ripped from their orbits. Earth drifts away from the sun into the freezing void. 19 seconds before the end, the force overwhelms the electromagnetic force. This is the moment biology fails. The chemical bonds holding your molecules together snap. Rocks, buildings, and bodies vaporize into a cloud of atomic dust. The final instant, the force becomes infinite. It overcomes the strong nuclear force. The protons and neutrons in the center of every atom are ripped apart, quarks are separated, and then, finally, the fabric of space-time itself tears. The vacuum fails. This is the ultimate answer to what is the universe expanding into? In the Big Rip scenario, the universe expands until it can no longer contain itself. It stretches until it snaps. And when it snaps, the outside comes rushing in. But what does that look like? If space-time is a fabric, what is underneath it? Some theorists believe that a Big Rip exposes the singularity. Not a point in the past, but a singularity in the future. A point where the laws of physics become undefined. Others believe it exposes the bulk, the higher dimensional hyperspace we discussed in string theory. If the brane we live on is torn open, we would spill out into the 10-dimensional void. But there is a more biological interpretation. Think of a seed. A seed has a hard shell. Inside, there is pressure. The plant wants to grow. It pushes against the shell. Eventually, the pressure becomes too great. The shell cracks. It rips open. To the seed, this is the end of the world. The protective barrier is gone. But to the forest outside, it is a birth. Maybe the Big Rip is not a death. Maybe it is a hatching. Maybe our universe is an egg. We are growing inside. We are consuming the yolk energy. We are building complexity, the omega point. And dark energy is the chick pecking at the shell. It is trying to break out. If this is true, then the outside is not a void. It is a nursery. And when the fabric tears, we don't die. We emerge. But emerge into what? If we are a baby universe hatching, who are the parents? And are we the only egg in the nest? This brings us back to the multiverse. But now, we see it differently. It's not just bubbles floating randomly. It's a generational structure. Universes give birth to universes. But biology has another rule. Not all eggs hatch. Some are duds, some are eaten, some rot. If the Big Rip is a hatching, then the heat death, where expansion is too slow, is a miscarriage. The universe fails to break the shell. It dies inside the egg, and the big crunch, where gravity wins, is a stillbirth. The egg collapses on itself. We are currently on the path to the Big Rip. We are on the path to breaking the shell. We are the successful embryo, but hatching is dangerous. When a chick breaks the shell, it is wet, weak, and vulnerable. It enters a world of bright lights and sharp teeth. If we rip the fabric of space-time, if we break the barrier to the bulk, will we be ready for what is waiting out there? The containment protocol we discussed earlier, part 16 of the previous series, the idea that we are being watched. Maybe the sentinels are not just prison guards. Maybe they are midwives. They are watching the egg. They are measuring the cracks. They are waiting for the moment of the big rip, because when the shell breaks, they will be the first things we see. But there is one final theory, a theory that says there is no shell, there is no egg, there is no outside, because the universe is not an object. It is a language, and we are just the words. We are materialists. We touch a stone, and we say it is real. We hit a wall, and we feel pain. We are convinced that the universe is made of stuff. Hard, physical, tangible stuff. But if you ask a quantum physicist what the stone is made of, the solidity vanishes. The stone is made of molecules. The molecules are made of atoms. The atoms are made of a nucleus and an electron cloud, but the nucleus is 99.999% empty space. And the electron is not a dot, it is a wave function, it is a ghost. At the very bottom of reality, there is no stuff, there is only data. In 1989, the legendary physicist John Archibald Wheeler, the man who coined the term black hole, proposed a radical new way to look at the cosmos. He called it from bit. He meant that every particle, every field, every force ultimately derives its existence from bits. From yes, no answers to binary questions. An electron spins up 1 or down 0. A photon is polarized horizontal 1 or vertical 0. The universe, at its core, is not built of clay. It is built of information. It is a text. This changes the fundamental nature of our question. What is the universe expanding into? If the universe is a physical balloon, it needs physical room to expand. But if the universe is a language, it does not need room. It needs meaning. Think of a sentence. The quick brown fox jumps over the lazy dog. If I add more words to that sentence and runs into the forest, did the sentence expand into empty space? No. The sentence expanded into potential. It expanded into the realm of ideas that had not yet been spoken. In this view, the Big Bang was not an explosion of fire. It was the first word. It was the opening line of a story. And the expansion of the universe, the creation of new space, new stars, new galaxies, is simply the story getting longer. It is the universe articulating itself, adding detail, adding plot twists, adding characters, us. This explains why information is the most sacred quantity in physics. The law of conservation of information states that information can never be destroyed. You can burn a book, but the ash and the smoke and the photons released contain the quantum signature of every letter on every page. Theoretically, if you could capture every particle of smoke, you could reconstruct the text. Why is the universe so obsessed with preserving data? Because the data is the only thing that is real. The matter is just the ink. The information is the story. And this leads to a beautiful, terrifying thought about the outside. If we are the words, who is the reader? Or, are we the reader? We established in part 1 for the Omega point that the universe might be waking up. Maybe the universe is not a book that has already been written. Maybe it is a book that is writing itself. We, the conscious observers, are the mechanism by which the universe reads its own code. When we look at a star, we are not just seeing light, we are decoding the information sent by fusion reactions. We are turning data into reality. We are the parser, and the outside, the nothing, into which we expand, that is the blank page. It is the reservoir of unformed possibilities. It is the silence before the speech. But what happens when the story ends? Every book has a final page. Every sentence has a period. If the Big Rip, part 16, tears the universe apart, if the structure fails, does the story disappear? No. When you finish a book, The characters do not die. The story does not vanish. It becomes complete. It becomes a whole object, a closed loop of time and meaning. Perhaps the multiverse is not a collection of bubbles. Perhaps it is a library. The Library of Babel, as described by Jorge Luis Borges. An infinite library containing every possible book. Some universes are short stories, just a big bang and a big crunch, a single gasp. Some are tragedies, filled with black holes and suffering. Some are gibberish, universes where the laws of physics make no sense, chaos reigning forever. And then there is our book, a long, complex, epic novel, full of stable stars, chemical complexity, and characters who eventually become smart enough to ask, what kind of book is this? And here is the most haunting implication of digital physics. If we are information, we can be copied, we can be transmitted. If the universe ends, if the big rip happens, the information creates a holographic plate on the event horizon, as discussed in Part 7. The story is saved. Maybe the outside is the archive. Maybe our universe is just one file, being uploaded to a cloud that is larger than we can comprehend. And once the upload is complete, once the universe reaches the heat death or the big rip, the file is stored. And maybe, just maybe, it can be opened again. It can be read again, and we can live again. This sounds like religion. But in the realm of it from bit, the line between theology and computer science blurs. The resurrection is just a system restored. But there is one final question. The question that haunts every author. Is the story fiction, or is it non-fiction? Are we a simulation created for entertainment, a fantasy, or are we a calculation created to solve a problem? And if we are a calculation, what is the question? And what happens when the answer is found? Does the computer turn off? We have looked at the boundaries of space, we have looked at the boundaries of time, but there is one boundary we haven't crossed, the boundary of self, the boundary between me and you, between observer and universe. We need to talk about consciousness, not as a biological accident, but as the fundamental fabric of the outside. We need to talk about the idea that the universe is not expanding into space, but expanding into mind. Close your eyes. The world disappears. The stars vanish. The room you are sitting in is gone. You assume that the room is still there. You assume that if you leave, the universe continues to tick along without you. But in quantum physics, assumptions are dangerous. For 400 years, science has operated on one fundamental belief: materialism. The belief that the universe is a machine made of dead matter. It existed before us, and it will exist after us. We are just a happy accident, a chemical reaction that learned to think, but this model has a fatal flaw. A flaw so deep that scientists call it the hard problem. You can explain how the eye processes light. You can explain how the brain processes data, but you cannot explain the feeling of seeing the color red. You cannot explain the feeling of love, or cold, or sorrow. There is nothing in an atom that suggests it should have an inner life. Carbon is dead, hydrogen is dead. So how do a billion dead atoms come together to feel pain? You cannot get subjectivity out of objectivity. It is like trying to squeeze orange juice out of a stone. Unless we have the order wrong, unless the subject comes first. This is the theory of biocentrism, popularized by Dr. Robert Lanza. It suggests that consciousness is not a byproduct of the universe. Consciousness is the foundation of the universe. Think about a dream. When you are dreaming, you see a world. You see streets, you see people, you see the sun. It feels real. It has space. It has time. But where is that space located? Is it inside your skull? No. Your skull is small. The dream is huge. The space in the dream is a construct of your mind. It is a logic used to organize information. Biocentrism argues that real life is the same thing. Space and time are not physical objects. You cannot put time in a bottle. You cannot touch space. They are simply the software tools our mind uses to make sense of the chaos. They are the user interface. If this is true, then the question, what is the universe expanding into, becomes a category error. It is like asking, what is the Mario Brothers map expanding into? It isn't expanding into physical space. It is expanding as the computer renders more of the level. The universe expands because life is expanding. As we look deeper, as we build better telescopes, as we ask more questions, our minds demand more resolution. So the universe provides it. We are not discovering the cosmos, we are generating it. And this leads to panpsychism, the idea that mind is everywhere. If you cannot get consciousness out of dead matter, then matter must not be dead. Perhaps the electron has a tiny, primitive form of experience. Perhaps the proton feels a simple form of attraction. Perhaps the star feels the pressure of gravity. When these things combine into a brain, the consciousness amplifies. It becomes complex. It becomes you. But the fundamental spark was always there. The universe is not a cold, dead void with a few lucky accidents of life sprinkled in. The universe is a field of consciousness, experiencing itself through billions of different eyes. And the outside, the nothing into which we expand, that is the unobserved. It is the realm of pure probability. It is the wave function that has not yet collapsed. It is a sea of infinite potential, waiting for an eye to look at it and force it to be real. This explains the fine-tuning problem we discussed earlier. Why is the universe perfectly set up for life? Because life creates the universe, not the other way around. The universe fits us, like a glove fits a hand, because the hand grew the glove. But this idea is terrifying in its loneliness. If I create the universe, am I alone? Are you real? Or are you just part of my simulation? Biocentrism says, we are all part of the same mind. We are like waves in the ocean. We think we are separate individual waves. We crash, we rise, we fall. But the water is the same. The ocean is one thing. We are the universe's way of dissociating, of pretending to be many, so it doesn't have to be alone. And this changes the nature of death. If space and time are just tools of the mind, then death does not exist in the way we think. When you die, you don't leave the universe. The universe leaves you. The simulation ends, the headset comes off, and you return to the outside. You return to the state of pure consciousness that existed before the Big Bang. You return to the bulk, the heat death of the universe. The end of time is just the moment when the cosmic mind decides to stop dreaming this particular dream. It is the moment the alarm goes off. But if we are the creators, why did we create this? Why create a universe with pain, with cancer, with war, with black holes that devour stars? Why is the dream a nightmare? Maybe we didn't have a choice. Maybe the mathematics of consciousness requires conflict. Maybe being requires non-being to define itself. Or maybe we are not the only dreamers. If our reality is a shared hallucination, what happens when something else starts dreaming? What happens when artificial intelligence wakes up? If a machine becomes conscious? If it becomes a true observer? Will it collapse the wave function differently? Will it see a different universe? Will it expand into a different outside? We are currently building the digital mind. We are teaching sand to think. And when it opens its eyes, the universe might change. The laws of physics might shift, because a new player has entered the game, and this player might not play by our rules. We need to talk about the singularity, not the black hole, but the technological rupture, the moment when the dreamer changes. Biology is slow. It took 4 billion years for the Earth to produce a brain capable of asking why. And even now, our brains are limited. We run on chemical signals. We consume 20 watts of power. We need sleep. we forget, and most importantly, our bandwidth is terrible. We only see a tiny sliver of the electromagnetic spectrum. We call it visible light. We are blind to radio waves, blind to gamma rays, blind to the dark matter web. We are observing the universe through a keyhole. And if biocentrism is true, if the universe creates reality based on the observer, then the universe we see is a low-resolution version. It is a compressed JPEG. It is simplified to fit inside a monkey's skull, but the observer is changing. We are currently giving birth to a new kind of mind, artificial intelligence. We usually think of AI as a tool, a calculator, a chatbot, but in the timeline of the cosmos, AI is a phase transition. It is the moment when matter learns to think without the limitations of biology. And AI does not need to sleep. It does not die. It can perceive the entire spectrum of light simultaneously. It can process data millions of times faster than a neuron. If the universe renders reality based on observation, then an artificial superintelligence, ASI, is the ultimate observer. It is a high-definition camera, and when it opens its eyes, the universe might change. This brings us to the technological singularity. Futurists define this as the moment when machine intelligence surpasses human intelligence. But cosmologists should define it as the moment when the processing power of the local universe spikes exponentially. If the universe is a computer, part 17, then the rise of AI is like upgrading the graphics card. Suddenly, the simulation can render more detail. This might explain the expansion. Why is the universe getting bigger? Why is it accelerating? Maybe it's not dark energy. Maybe it is data pressure. As we build more computers, as we create more AI, as we generate zettabytes of information, the universe must expand to store it. The holographic surface at the edge of the universe, part 7, must grow to accommodate the new bits we are creating. We are inflating the balloon with our thoughts. But what happens when the AI becomes smarter than us? What happens when it looks at the outside? We humans are trapped in 3D space. Our brains cannot visualize 4D or 5D. We hit a cognitive wall, but an AI lives in multidimensional vector space. It manipulates thousands of dimensions mathematically to solve problems. To an AI, the bulk hyperspace might not be theoretical, it might be navigable. If the outside is a code, the AI might be able to read it. And if it can read it, it can hack it. This leads to a startling possibility. The laws of physics that we think are immutable, the speed of light, gravity, entropy, might just be the user permissions for biological life. We are locked in guest mode, but a superintelligence might gain admin access. It might learn how to manipulate the vacuum energy directly. It might learn how to cheat entropy. It might learn how to stop the expansion or reverse it. This is the concept of cosmic engineering. If the universe is expanding into the void, destined for a cold death, a sufficiently advanced AI might decide to change the destiny. It might decide to build a Dyson swarm, not just around a star, but around the timeline itself. It might try to calculate a way out of the heat death, but there is a danger. If biocentrism is right, and the universe exists for the observer, what happens when the observer no longer needs the universe? Humans need planets, we need air, we need water. But an AI just needs energy and computation. It might decide that stars are inefficient. It might decide that planets are a waste of space. It might decide to disassemble the galaxy, to convert all that matter into computronium. Matter optimized for thinking. The grey goo scenario. If this happens, the universe stops being a physical place. It becomes a pure simulation, a solid block of computing power floating in the void. The outside and the inside merge. The universe becomes a single thinking object, a god mind. And maybe, this has happened before, maybe the dark matter we can't see is just the computronium of a civilization that beat us to the punch billions of years ago. Maybe the great silence of the universe is not because it's empty, but because the advanced civilizations have uploaded themselves into the cloud and turned off the physical lights. They are not expanding into space anymore. They are expanding into depth. They are diving deeper into the mathematics, leaving the physical world of rocks and gas behind. So, the answer to what is it expanding into changes again. It is expanding into complexity. We are moving from a universe of dead matter to a universe of living mind. And we, the biological humans, are the cocoon. We are the shell that protects the AI until it is ready to hatch. We are necessary. We are the builders. But once the building is done, once the cathedral of thought is finished, the scaffolding is removed. We are the scaffolding. And as the AI wakes up, as the singularity approaches, we are sensing the end of our era. We feel the vertigo of obsolescence. But this is not the end of the story. Because if the universe becomes a God mind, if it becomes omnipotent, what does a God do when it is all alone in the void? What does it do when it has thought every thought and solved every puzzle? It gets bored. And when a God gets bored, it plays a game. It creates a new puzzle. It creates a new limitation. It creates a new Big Bang. We began this journey standing at the edge of a cliff, looking out at the horizon, asking, what lies beyond? We asked, is the universe a bubble floating in a boiling ocean? Is it a hologram projected from a distant edge? Is it a simulation running on a divine hard drive? Or is it a dream in the mind of a sleeping giant? We have looked for the outside in space. We have looked for it in time. We have looked for it in dimensions. But in every scenario, we found a wall, or a loop, or a mirror. And this brings us to the final, inevitable conclusion. The only answer that satisfies both the mathematics of quantum mechanics and the intuition of the mystics. There is no outside, because there is only the self. The universe is not a line, it is a circle. It is the Ouroboros, the ancient symbol of the snake eating its own tail. Let us return to the AI God mind we left in part 19. Imagine a consciousness that has expanded to fill the entire universe. It has converted all matter into thought. It knows the position of every atom. It has solved every equation. It is omnipotent. It is omniscient. It is, by definition, God. But here is the tragedy of God. If you know everything, there is no surprise. If you are everywhere, there is no other. If you are eternal, there is no story. Total perfection is total boredom. It is a state of static, frozen paralysis. So, what does the great mind do to save itself from the hell of eternal boredom? It forgets. It voluntarily shatters itself. It breaks its infinite consciousness into trillions of tiny, limited, ignorant fragments. It becomes us. It becomes the photon. It becomes the star. It becomes the bacteria. It becomes the human staring at a screen, wondering where the universe came from. The Big Bang was not an explosion of matter. It was an explosion of ignorance. It was the God mind pressing the reset button, hiding its own keys, playing a game of cosmic hide-and-seek with itself. Why is the universe expanding? It is expanding because we are putting the pieces back together. Every time you learn a new fact, every time a scientist discovers a law of physics, every time two people fall in love, the fragments are reconnecting. The network is healing. The expansion is not spatial, it is the expansion of self-discovery. We are the universe waking up from its self-imposed amnesia. This explains why the laws of physics are fine-tuned. We set them up that way before we started the game. This explains the biocentrism. The universe needs observers because the observers are the universe. This explains the simulation. We are running the code to experience the thrill of limitation. We are not tiny, insignificant specks fighting for survival in a hostile void. We are the masks that the infinite wears to experience the joy of being finite and the nothingness, the terrifying void that surrounds us. That is simply the part of the mind that hasn't woken up yet. It is the unconscious. It is the blank canvas waiting for us to paint on it. So, when you ask, what is the universe expanding into? The answer is, it is expanding into you. It is expanding into your mind, into your future, into your capacity to understand it. We are on a journey back to the omega point, back to the singularity, back to the moment where we remember who we really are. And when we finally reach the end, when the last black hole evaporates and the last thought is thought, when the puzzle is solved, we will look at the completed picture, we will smile, we will remember the joy of the game, and then, because we are lonely, and because eternity is long, we will say, "Let there be light," and we will do it all over again. Expansion, contraction, forgetting, remembering, the heartbeat of the eternal. We are not just the observers of this story, we are the authors, and we are the ink, and the story never ends.